Good morning, everybody. So I'm going to talk about lean software development, recognizing that my experience with lean comes from the mid-'80s, before there was a word called lean, when I was in a manufacturing plant as IT manager. And we switched to a just-in-time system with a massive quality program. We threw out all my computers. You know, we turned off the MRP. I've been there. It made so much sense. It so much improved our plant. We didn't have any trepidation about it because we were being killed by Japanese competition, and we decided we couldn't figure out anything better to do than to copy them, so we did. And it worked really well. So I did a manufacturing, swap over to pull system with very strong improvements in our quality. And Tom and I have been going around the world talking to people, mostly people that do software and people that lead software development and how they do it and what works and what doesn't work in the context of lean software development, which I guess I would call the theory behind why Agile should work. Two very, in my opinion, distinct pieces. One piece is operations and perhaps support, and the other piece is application development. And I would propose in the lean world that you make a very strong distinction between the two in any lean initiative, because they're very different thinking processes. So standard lean tools really work in IT operations and oftentimes in support environments. They do not work in application development. And when you're doing development, and I mean all kinds of application development, that's what you're doing. You are creating the recipe which will then be used by somebody. If you think about it that way, then you have to think differently about the toolkit. Okay, so there is an operations toolkit for lean, and there's a development toolkit for lean, and I suggest they're different. Even the Six Sigma folks finally figured this out. They got Design for Six Sigma. Not that I agree with how that works, but the concept of going into development or design with standard operations tools is probably not what you want to do. So we talk about standard work, and that's interesting in an operations environment because you do the same thing again and again and again. And in design, there are a few things that you do repeatedly, and you probably want some standards and some standard work. Mark said that in Google, they have one configuration management system. Those of you in software know that's always a point of argument about which configuration management system, and do we just have one? But they have some standards, and they have certain ways of doing things. They build only from the trunk. They do not build in separate segments. There's lots of standards, ways, but the real thing that's important, the lever, if you want to get a lever to make stuff change, you don't go here. The standard work is not the place to go for a lever for making things better, okay? What you really want to think about is that development is a learning cycle activity, and your lever is the learning cycles. Okay, so you want to think about how you create a constant learning cycle lever, and that's your basic thing to focus on. Well, you know what? Projects are almost exactly the same thing. They're detailed scheduling of how I'm going to solve a problem, and it's exactly the same thing. You've got to get rid of that concept, pull those computers out that are managing how tasks are done, and manage flow. You can manage flow in projects. It's not really too hard, actually. The first thing you have to do is get in your head, that's the game. Manage the flow of work, not tasks that have deadlines. So when we have projects, and especially big projects, we have what? Big batches of stuff. And so therefore, we have a long feedback loop, and we have something as all kinds of little things we're trying to schedule, which we've already learned in Lean we can't do. We throw out the scheduling system, and we manage the flow. So when you look at iterations and in the typical Agile environment, they are mechanisms to manage flow as opposed to manage completion dates. And steady, even flow without variation, that's good. But, you know, our project mentality has given us uneven flow of work through our system. Big project approvals and massively uneven flow. So as we try to hit all those deadlines and can't, we create even more oscillations. And so what you got to do is make sure that the people who are developing the software learn how to think like customers. And this is a quote from a guy at Tandberg. Tandberg makes these very big video conferencing systems, really high-end video conferencing systems. It's in Oslo. It's now been purchased by Cisco, one of my favorite companies. And their founder said, you don't do what customers say they want, you understand their problems and solve them. And I don't care if this is application development in a process environment or if it's product development. You need to understand your customers' problems and solve them. You do not do what they say. Order taking is not the concept. So let's go to waste one, extra features, unnecessary features. And this is a study from the Standish Group in 2001, I think, that said that a whole bunch of features and functions, like something like 2/3 of features and functions in a custom system, that's what IT organizations do, custom systems usually, or they take and buy stuff and modify it, but anyway, 2/3 are seldom or never used. These are features that never needed to be there in the first place. Now, I wouldn't be citing a really old, small study if I hadn't gone around for a decade and asked virtually every audience I talked to, does this feel like your world? And guess what? This feels like the world of huge, huge percentage of software developers, right? Anybody in software, does this feel right? We had all these extra features in our code base. Nobody's using them, never needed to be there. This is really, really common. Okay, you want to know your best chance to get more time? Stop putting in features you don't need. Simple. Really hard, but actually it's the most fundamental thing if you want to be lean in software is write less code, fewer features, less stories, only the right ones. Now you know that when you do process improvement, you want to focus on one thing at a time and get it right. And so why don't we do that in software? I mean, it's the same concept. Waste two, handovers. Now according to Alan Ward, who wrote Lean Product and Process Development, he says this is the biggest waste in product development, and I think he's probably right for product development. Handovers are the biggest waste. One person figures out what to do, one person figures out how to do it, third person actually does it, somebody else learns from the feedback. So that set of handovers, what it does is loses knowledge. Knowledge doesn't pass with handovers, certainly not with paper handovers. So a process which has lots of handovers in rather than getting the people who implement understanding what they're trying to do is a process that will lose all kinds of knowledge. That's the first waste in software, really too much stuff. And you've got to attack that, and that is not attacked by saying, I've got a big project, let's do it, and make sure it's done on time. It is attacked by saying, how small can I make the project so that I can get it out there, get feedback, and then modify the second step? So it's definitely, you attack this by small experiments, not by big projects. Big projects are big batches, no feedback. They just, you know, the smaller you can make them, the better life will be. Okay, and then build the thing right. So this is a fact. If you look at the waterfall process, if you look at Agile, you look at any process out there, the express purpose of every software development process there is to find defects early rather than late. Yes? Because they cost a lot less at the front to fix than at the back to fix. So nobody will argue with the fact that you need to find defects early rather than late. The question is, how do you find them? And in fact, defects that are hidden and you find later are a huge waste, massive waste. They cost a huge amount of money. It's just that Mark told us this morning how you find them. You create sort of like a double entry bookkeeping system where you've got to add both ways, and every time you put your code together, the unit tests and the new code have to add up, and all those old unit tests that are making sure that the old code hasn't been touched add up. And so you create a harness, a test harness, like you would do in a semiconductor factory. Put your chip in a test harness. Similarly, you create a test harness so that you can find these things, and then you can very rapidly, like what they can do it. He said that probably they can be pretty much comfortable every hour that they have a releasable thing, surely by the end of every day. And I've worked with companies that release every day into live, you know, onto their main trunk website, public for everybody. And every company that does that finds it amazingly effective. So another thing is technical debt. Technical debt, we heard the term, it's anything that makes code difficult to change. Because guess what? You know, the waterfall process was designed under the thought process that we want to build it right the first time and then never change it because, you know, it's kind of hard to change. Actually, it's really hard to change. Well, how well has that ever worked? Code will change. Code, that's the purpose of software, is to change. It changes when everything else, all the hardware and stuff, doesn't change. And yet we have a process which bakes in rigidity. So we got to go to a process which makes things easy to change because change will happen. So you need to make sure that your code is not sloppy, that anybody can read it and figure out what it's doing. You need to have a set of test harnesses because code without test harnesses is pretty much the definition of legacy code. You need to make sure that you have a very good architecture so that the stuff likely to change will be together and the stuff unlikely to change will be down a different branch. You need to have your code branches synchronized all the time. You need to merge not once every 3 months or once every 6 months. You need to merge all the time, and not just merging of your current code into your current application, but merging of all of the branches into your production or trunk branch. That's why Google can do this, because they're doing that merge every day. Delays are basically opportunity cost that's gone, and many other things. So that's a waste. And now I'm going to just sort of quickly go through this concept of speed that, that really might sort of give you a feel for how to think about this. So if I want to know what kind of process a company uses, here's the question I ask. How far apart are your live releases? How far apart, okay? So anybody here have 6 months or more? Yeah. And so if you have 6 months or more, this is very classic, especially in IT departments. Here's a quick and dirty value stream map. I've got some others in the other slides, but this is for just now. So here's your release cycles, right? And I will bet you that you spend something like maybe a third of your release cycle hardening. Maybe? Yeah, something like that. Okay? And then maybe you select features before the cycle starts, typically. And that's a governance issue. There's nothing technically that says you need to select those features at the beginning. It's just that it's governance. The fact is you could be selecting features and should be selecting features all the way through here. But when they have long release cycles, an organization almost never has incremental feature selection. They put it all at the beginning, typically so that they can measure whether or not they're all done. And then we have development in there. And then maybe you deliver the software to some other customer instead of internal. And then you have another user acceptance test. And finally, they're actually getting some value. Now, when did they request this? Well, if they requested it, they must have, if you selected the features here, then you take 6 months and say during the 6 months before, they were requesting features, yes? So you take the average of that and say the average feature maybe came in here. And the average feature gets out there. So there's your total cycle time. Now let's say in the 6 months you do something like 20, that'll vary, but for this case, let's say maybe 20 features. There's your value added time. Okay, like that, really slow, but it gets worse. You didn't just take the things that came in the last 6 months. You had this big list of other stuff to consider. And so probably the stuff came in like here or more. And so we're talking about if we have a 6-month release cycle, you know, well over a year before anybody gets anything that has average priority. And maybe a 1 or 2% value added time to total cycle time ratio. And then they're really fast, okay? The ones that are doing the continuous delivery. The ones like Google and Facebook and who else did he say? I think Amazon does this. But we've seen a lot of companies recently. The little, well, as I said, the website that does job postings, they've been doing this for years. The little company in Prague. And they have a massive code base, And what they're doing is credit card transaction processing for web-based things. So they don't have little things you can put your cards in. But if you have a web-based business and you want a merchant account that costs half of what the other ones do, then that's what their business is. And they release, I think, every week. And I know that Facebook releases small things every day and one big release a week. And as Mark said, Gmail releases twice a week. And it's more because they create so much waves in the rest of the code base that other teams wanted them to slow down. So this is something you can do. But you have to have a different way of thinking about what is lean in a development environment, how do we measure what good is, and get rid of the stuff that you've been measuring just because you could, and start measuring the stuff that's really the lever. Yesterday, we heard, it was in response to a question, how do you measure whether something's good if you can't measure productivity by, lines of code? And who was it that said, pardon? I can't remember his name. He said, what you want to measure is how much of the stuff I put out there is being used. How many calls are there to the help desk? Now, those are great measurements. So think about, how do you measure productivity? I would measure by whether or not the people the business purpose for which the code was developed is in fact being served.
Well, thank you very much.